Many tobacco products used today, such as vapes and cigarettes, contain a chemical called nicotine. So what is nicotine? Nicotine is a highly addictive chemical that can increase blood pressure and heart rate. When nicotine is ingested into the body, it makes the user more alert and aware of their surroundings. When nicotine leaves the body after 1 to 3 days, symptoms of withdrawal can range from sadness or depression, the urge to smoke again, and having a hard time concentrating. So how does nicotine have this effect on our bodies? Nicotine inhibits the cholinergic pathway by binding to nicotinic acetylcholine receptors, which leads to a chain of events. But to understand this, let's first take a look at how the cholinergic pathway works normally. Acetylcholine receptors are found throughout the central nervous system and the peripheral nervous system. In the cholinergic pathway, there are two types of receptors: nicotinic acetylcholine receptors, which are ligated ion channels, and muscarinic acetylcholine receptors, which are G proteins. Acetylcholine can bind to both of these receptors, but only nicotine can bind to the nicotinic acetylcholine receptors, so those are the ones we will be focusing on. In the presynapse, acetyl coenzyme A is transformed into acetylcholine with the help of a key enzyme, choline acetyltransferase. It is then loaded onto vesicular acetylcholine transporters. The vesicle containing the ACH will fuse to the presynaptic terminal, and then ACH gets released into the presynaptic cleft. So let's take a closer look. ACH, which serves as a ligand, binds to the ion channels in the postsynapse and opens the gated ion channels. Once these channels are open, calcium and sodium ions flow through the cell, leading to the depolarization of the cell. Calcium acts as a second messenger and binds with calmodulin, making CAM kinase 2, which plays an important role in neurotransmitter secretion. The energy from the ions passing through and into the cell then trigger postsynaptic events, in this case being muscle contraction. Now let's rewind all the way to the beginning and see how nicotine can affect this. Nicotinic acetylcholine receptors are called this because nicotine acts as an agonist, making it possible for them to bind to the receptors also. In the central nervous system, when nicotine binds to the receptors, a greater influx of calcium and sodium enter the cell and CAM kinase is made again. This leads to the secretion of dopamine, serotonin, and norepinephrine. The increase of dopamine and serotonin levels are most likely linked to the rewarding or addictive qualities of the drug, and norepinephrine to the stimulation and arousal of the drug. When nicotine binds to the receptors in the peripheral nervous system, the depolarization of the cell causes a secretion of catecholamines, like epinephrine, from the adrenal glands, which leads to increased sympathetic activity like high blood pressure and heart rate. Prolonged nicotine activity causes the receptors to become unresponsive. The brain decides to upregulate and add more acetylcholine receptors, which are most likely responsible for the withdrawal symptom of the craving or the urge to smoke again once nicotine administration has ended. So that's how nicotine inhibits the cholinergic pathway. Thank you so much for listening, and remember, say no to drugs. They are very bad for you.